The idea behind overflow is that an integer only has a certain number of bits dedicated to it. And nowadays, 32 bits. And if the number gets too large to be held in 32 bits, if it gets larger than 2 billion whatever, 2 billion and change, whatever the limit is, then it can't hold it anymore. Is it going to go kablooey? Is the computer going to explode? Is the program going to crash? No, it's just going to cheerfully chop off the top bit and then go ahead and use what's in the rest of it, which is no longer going to be correct at all. So a famous example of overflow, and if you've taken some of my other classes, you probably have already seen this, but it's a really easy one to show you, is Pac-Man Level 256. Now I think everybody, well, maybe not anymore, everybody knows the idea of Pac-Man. Is the game supposed to look like that? No, it's not. I mean, it's not crashed, but it's not working right. And you can't finish that level because you can't eat the right number of dots to go to the next screen. What has happened here is that it kept playing and it kept working all the way up to level 255. And if we do bits, if you have 8 bits, you have 0, 0, 0, 0, 0, 0, 0, 0, all the way out to 1, 1, 1, 1, 1, 1, 1. And if we were going to add that up, that's 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is equal to 255. That's the largest value that can be held in a 1-bit value, in a 8-bit value. So, when it needed to add one more, we've done bits in binary, have we not, in this class? Okay, good, good, good. So when it needs to add one more to that, all these would roll over back to being 0, and it would try to put a 1 there. But it can't do that because it's only an 8-bit number. So you add 1 to that, and you get the largest bits cut off, and you get that. The program doesn't know how to draw level 0. It crashes for whatever reason. There are people who have fixed, there's a thriving community of people who like to play the old video games, and so, they load up in emulators or whatever, and some people have actually burned new ROMs, put them in the machine that has the bug fix so that, merely playing, 8 straight hours of Pac-Man wasn't enough. You could play forever. So whatever. That's the idea behind overflow. Overflow is when the number gets too large to hold into the number of bytes allocated for it. Messes things up. It's no longer a valid value. Let's write a little example of overflow. We're just going to keep multiplying a number by 2 until it gets too large. So I'm going to do a file new, as usual. File new project. Don't do file new C++. Do file new project. Make a whole new project. C++ empty project. March 1. Why is it not creating it?
Folder location.
Aha! Apparently it's not supposed to store it down in the Visual Studio document. Okay, so just click Browse, go to Documents, and put it there. Or maybe in Visual Studio. Projects. Select Folder. Is that going to do it? Hope so. Yay. All right, so that's the right place. To reiterate, file, new file, project, choose your type, click Browse, and go to Documents, Visual Studio 2013 Projects. Then you'll be good to go. If you can't find your Solution Explorer window, go to View, Solution Explorer. Right-click on Source Files, add a new item. I'm going to change mine to March 31.cpp. I'm going to leave it source.cpp. Whatever. All right, now my usual boilerplate. I'm going to read it off as I say it, as I always do, but you ought to know it by now. Pound sign include IO stream. Pound sign include string, which we don't use very often yet. Using namespace std, semicolon, int main, in parentheses, in parentheses, system pause. Seemed like one of y'all was having trouble. Maybe it was Daniel. That started malfunctioning towards the end of class. That was pretty weird. And then a return 0. All right, let's write a little loop. I'm sure we haven't talked about for loops yet, although you have in other classes, so we're just going to use a classic while loop. Okay. So yeah, let's start a variable off as 1. And I'm just going to make this a while true loop, so it'll run forever. No, maybe not. How am I going to do this? And then we need a counter. Int I is equal to 0. And we're going to double the number, I don't know, 30 times and see what happens. So while I is less than 30, x is equal to x times 2. That seems awfully familiar. Did we write this very loop on Monday? Alrighty. And then let's add 1 to I. So this counter is just to make sure it's not an infinite loop, right? If 30 isn't enough to induce overflow, then we will keep increasing it. But let's print out the value of I and x. So cout I followed by a space followed by x followed by ENDL. Please tell me I have the recorder going. Yes. Don't put a semicolon here. That'll make an infinite loop. We found that out on Monday. Some of us did. And I didn't show that to everybody. But if you put a semicolon there, it's the same as doing this, putting some empty braces there. So it's just going to repeat nothing forever. Why is it going to be forever? Because nothing ever updates I. You always have to have something that updates your loop control variable, or something to that effect, or else this case never becomes false. So if you put a semicolon there, it breaks it. That's one good reason. That's one argument for putting the brace on the line, on that line, rather than hitting enter like I do. Because then you would see, well, that looks really weird, right? So maybe someday I'll switch over to doing it that style. But you'll get used to it. If statements, while statements, do not put a semicolon there, ever. All right, let's run it. By the way, do not check that box that says, don't ask me again. While. That wasn't large enough. Doubling it 30 times wasn't large enough. But if you run it and it says, would you like to build it? Yes. And then if it finds an error, right? This one's okay to say, do not show this dialog. You always want to build it. But if it comes up and says there are errors, would you like to run it anyways? Never do that, and especially don't choose that. That would be bad. Why? Because it's not going to show you that there were any errors, and it's going to run the last version. And you're going to get very frustrated because you won't be able to see your changes. So never choose to run it even though there were build errors. Correct my mistake. Now 40 was not enough. excuse me, 30 was not enough. It doubled itself 30 times. Maybe 32 would have been enough. I'm going to change it to,
35.
you've already tried it? Okay, I'm going to change it to 35. I bet 32 would have been enough. Let's give it a shot. Just because 2, 4, 6, 8, 16, 32, that's why I'm predicting. Okay, there we go. Check it out. The 31st time it doubled it, it went negative. Well, why did it go negative? And then after that, it was just completely botched, and it was 0.
Or constant equals 0.
Yeah, the reason it went negative is because the first bit of an integer that's not an unsigned integer is dedicated to a what's known as a signed bit. And if that bit is set to 1, then it means that it's a negative number. So if we go back to our little sheet that I was writing here, if by the time you had this 0, 0, 0, excuse me, 0, 1, 1, 1, 1, 1, 1, 1, and then you added one more to it, that would become 1, 0, 0, 0, 0, 0, like that. And it's going to see that bit there and think it's a negative number if this was a signed value. It's not a signed value, so it gets to use a whole, I mean, Pac-Man wasn't using signed values, so it got to use all the bits. But if it was a signed value, this expresses the magnitude of the value up to 127, and this controls whether it's a positive or a negative number. Now, it's slightly more complicated than that, but I don't want to get into that. So it uses something called 2's complement. If you ever have to learn it, you will. That's the idea. That's why it flipped to negative. Because once it got larger than that, and it started putting a bit there, then it reported it as negative. Now, as to why it went 0 on the very next doubling, I'm not sure. But obviously the data is corrupted. That is overflow. Overflow is when a value exceeds the limit of the data type. Underflow is when it gets too small. Same kind of deal. Floating point numbers, support both positive exponents, like a double can hold, something times 10 to the power of 308. They can also hold negative exponents, something times 10 to the power of negative 308, but if it got smaller than that, it would just, be all zeros, and it would not be able to go anymore. So it wraps around, right? It went from positive to negative. Or Pac-Man went from level 255 to 0. Different systems may display a warning error message. It may stop the program if something in it detects, or it may just keep running using the incorrect value, which is what Pac-Man did. Hey, cool, I'm back on level 0. There never was a level 0. It didn't know how to draw it, but it didn't know that, so it went on its merry way. So did our program. Our program didn't care that the data had been lost. It just kept trying to double it, and once you start trying to double 0, it stays 0 forever. So that's the idea of overloading. If your program starts getting overloading, you go to the larger data type. If int doesn't work, you go to long, because it's twice as wide. It's 64 bits wide. Let's change our int to a long and see how long it takes for it to break. So I'm going to go back up here, and where x is equal to 1, x is the value that we'll keep doubling. I'm going to change that to long. It's obviously not, okay, I need to close my app here. It's obviously not going to break at 32 or 35. I'm going to change it to 64. Or 100. Why not 100? Yeah. So, while I is less than 100, let's see when it breaks there. Okay, it does break. At iteration number 63, it flipped to negative, and then after that we were completely gone. Right? Didn't work at all. But we got a lot farther. Right? That's the maximum value of, 2 billion is the maximum value of an int. it got much larger, you know, to 4 super quazillion, whatever that is. If we used an unsigned int, it would go 1 further because we'd have that extra bit to play with. So it might not crash at 63, it might go to 64. I feel like making that change just to experiment. I hadn't done this before. So I'm going to go where it says long, I'm going to make it unsigned long, and run it. And it probably gets 1 further, just because it has that extra value. Well, yeah, it did. 63 was not negative. 64 was still goofed, but at least 63 was not negative, so it got 1 further. So for 8 bits, a signed 8-bit value, which there really isn't, could go from negative 127 to positive 127, whereas an unsigned 8-bit value could use all of the bits and could get up to 255, 0 to 255. You see how it covers the whole span? Unsigned 16-bit could go from 0 to 65535. I don't expect you to memorize these numbers. But if it was signed 16 bits, it would be half that, whatever that divided by 2 is. Negative 32,000 or whatever to positive 32,000, whatever. That's not precise. You know, it would need to be exactly 655. All righty, thanks.
Alright, so when you're using those or choosing to use those, you just use whatever best fits your program at the time? Or
Right. Generally, my brain, I go, okay, I'm going to use ints just by default. But, you know, if it needs to hold just a little bit more and you know that it's never going to go negative, you could use an unsigned. But typically, if it's not large enough, you just flip over to the next one. You go from int to long, or you go from float to double.
would there ever be like a wrong time to use just the biggest one, just in case anything didn't happen?
Using double instead of float is considered standard practice. Use a larger one. Using long instead of int, for some reason, is not quite as accepted. I'm not sure why, except probably math on ints takes a little bit less time than doing math on longs, and also a long allocates twice as much memory as int. But the same could be argued between a double and a float. So I don't know why it's industry standard practice to always use doubles rather than floats, but not always use longs rather than ints. If you feel like always using longs, that's totally cool. On the other hand, if you're asking someone for their age, and the only values they're ever going to type are something between 0 and, you know, what's the upper limit for somebody's age, 120, something like that, you don't need 64 bits to hold their age. That's a bit much. So
Gotcha.
you just kind of size it to the data size. It's a good generic choice.
This one I cannot run the program anymore.
Let me come look. Do that. Go to the place where it says times equals 2 and make it, actually it's not saying times equals 2. I could have rewritten this as times equals 2. That means double it each time. That would have been the same thing. But now I want to triple it each time, just for funsies. It's going to overflow even faster. But you can watch it. It gets larger and larger and then larger and then larger, and then boom, it starts getting corrupted there. How do we know that? Well, because it didn't get any larger at that point anymore. And then it shrank. And if you're multiplying it by 3 each time, it's not, you know. So you can tell that we have suffered overflow at that point. Are we done with the rest of the chapter? I think we just about are. So you can do plus equals to represent the same as that, just like I did times equals 2 to mean taking that number and multiplying it by itself. Formatting your output, we talked about that. I haven't given you an assignment based on that, I do not believe. I don't consider it the most important thing in the world, just because it differs so dramatically from how other programming environments do it. I may change my mind on that. Okay, we weren't done. Don't think. Working with characters and string objects. use CIN to put into strings, but it causes a problem. Let's play with that, or it can cause problems. Close all your currently running versions. Let's just stick our code up at the top. Let's do a cout, enter name, colon, end quote, backslash. What did I do wrong? I did the arrows the wrong way. Yep. Okay. Now let's declare a variable called name, and let's read into that. Now let's ask for their age. Cout, enter age, colon, space, end quote, semicolon. And it doesn't matter whether we make it a float or, let's make it a float. Let them type in 12.5 as their age if the kid is that obsessed enough with his age. Okay, so float age, and then CIN into age. Now let's just print that stuff back out. Cout, age equals, end quote. You caught me. Thank you. Arrow's going the wrong way. Cout, less than, age equals, end quote, less than, age, less than, ENDL. And do the same thing for their name, which I should have done above it, right? But whatever. Cout, less than, name equals, end quote, less than, name, less than, ENDL. Now the program's going to work fine. And by the way, our overflow example is going to get really annoying each time we run it. So why don't we change the maximum from 100 down to 10, right? Just to stop it from doing that. So go down to your while loop and lower that a lot, or make it, 1. I don't care. How about 5? We're going to watch it double itself 5 times. It's not going to illustrate overflow at 5, but I don't want to see that every time I try to run it. Okay, enter the name. Type in a first name. I'm going to change my properties, make the screen a little bit larger. Uno momento. Alrighty, enter name, Joe. Enter age, 30. Okay, woot, it worked. Big surprise. Now run it again, but type in a full name with a first and a last. Enter name, Joe space Bob. Whoops. Not good. Didn't work. And the reason why is because CIN does something called tokenizing. Tokenizing means it breaks it up by white space. And that white space could be the inner key, or it can also be the space. And so what it did is it read Joe, it went ahead and stored that in the name string. That left Bob hanging out there, ready to be read in. And so when we tried to read in age, it just stored that string Bob right into age, and the conversion completely failed. It didn't blow up. Unlike Python, remember wherever you did like an int or a float, but the user typed in a word instead, it would crash? No, it just doesn't work. Gives you really bad results. If you have to, you can get around that. If you want to let them enter both their first name and their last name, I can't believe I'm losing my voice. Alrighty, then you can use getLine. Now using getLine can get frustrating, but what we could do is this. I'm going to change that inner name part from this. I'm going to just comment it out. You see I commented that line out? Now I'm going to use getLine, reading from CIN into the name variable. That gets an entire line of stuff. It doesn't break it up by spaces, it reads in an entire line. That's how the Python input statement works, right? If you type input in Python, it gets the entire line of data. Well, that's what this does. However, this is for strings only. And remember in Python, every time input was called, it returned a string, and then you had to convert it to a float or an int. Same kind of business. If you wanted to use this to get, numbers, you'd have to convert them yourself. Whereas CIN, arrow, does it automatically for you. Alrighty, enter name, Joe, Bob, enter age, 30, and it's back to working. It can get to the point where when you're mixing get line with arrow, greater than, it stops working right. And you'll see it skip your input prompt. They won't get a chance to type something in which case you have to start wrestling with it a little bit. You have to kind of put your head against the keyboard a couple of times. You wind up having to clear the input buffer in order to do that. But this time it worked. I'm happy about that. So that's what getLine is used for. The way it works, the syntax for it, is getLine, followed by the input stream, and so far the only input streams we've ever used is CIN, and then the variable name, like that. That's how you read it in. I think I'll just copy that entire thing, paste it in here. I never actually stated what overflow was, so overflow exceeding. I did in the other code, though. The max value a data type can hold. Remember the Pac-Man example and the doubling example. All right. Working with characters and string objects. If you just want to read a single character, you can use cin.get. You can pull out just one character, including even white space. Let's play with that and see if we can get that to work. So I'm going to define a character. I guess I'm going to put it below my couts here. Right? Above my unsigned long. Character CH. I'm going to tell them to press a character. So cout less than, quote, press a key, end quote. And by the way, I haven't been walking around to make sure that y'all aren't getting syntax errors. Please model yourself after Daniel, who did get me to go over there. Wave your hands if you need help, or yell slow down, or throw a shoe at me, whatever. I'll do a walkabout in just a second. All right, and then cin.get into that variable we just created, ch. And let's just print that one out. ch equals, end quote, less than, ch, less than, endl. Now when it said press a key, I just hit the enter key. That's not quite what I didn't remember what I was trying to do here. Check it out, it's not giving me a chance to press enter. It's apparently got something left in the buffer. And that's probably from mixing getLine and arrow. And I'm not going to take the time to try to fix that. I'm tempted to keep working on it, but I don't think it's important enough. Just remember that .get will pull out a single character, whereas getLine will pull out an entire line. Here's our example of it. Character, ch, cout, strike a key to continue, and then cin, arrow into ch. Hey, that would have been a good thing to do instead of system.pause, right? Yeah, it would be a great thing to do. Why? Because Macs and Linux don't have a pause command that you can execute with system the same way. Why don't I do it? Well, for one thing, it's a lot easier to type system pause than to type those 3 lines of code. And for another, you just saw that cin, arrow, ch, or doing that wouldn't work. But that's what they're showing here. Press enter to continue, cin.get. Press enter to continue, cin.get. Press enter to continue, enter to continue. Likely that if we took out that get line, it would start working. As a theory, I'm going to comment the get line out. You don't have to do this. And I'm going to uncomment that one out. I just want to see if it works the way it's supposed to work. There were build errors. No, of course I do not wish to run it. That's because what kind of comments did I use there? The wrong kind. Alrighty. And you really don't need to make the changes that I'm making right now. Nope, it still didn't give me a chance to press a key. Pretty mysterious to me. I could force the issue by clearing the buffer. I'm not going to bother showing that to you. So as a result, I just don't use cin.get very often. I'm going to undo those changes because I liked them. I'm recommenting out cin into arrow name, and I'm uncommenting out the get line. All right, good time to wander around now that I've made changes and unmade them. So into our notes, I'm going to say using cin arrow arrow will only get one piece of data. If there are multiple pieces of data on the line separated by spaces, they will be left for the next arrow arrow to capture. Now sometimes that's okay. Like what if you did this? Cout, don't type this in your code, this is notes. If you're typing notes, great. Enter first and last name. That's okay. And then cin into first, into last, like that. That would work. Why? Because it would read the first name into there, but it would leave the last name out hanging on the keyboard buffer, and then when we did another arrow, it would get stored in the last. Cool deal. So if we did this, cout, give 3 numbers. This is almost worth doing actually in our code. Prepare yourself. We're going to put this right under the line main, where it says int main. We're going to be putting this in there. Cout, give 3 numbers, endl. Then do this, cin into A, into B, into C. I haven't declared A, B, and C, so this isn't going to work. And then cout A and B and C, like that. I never declared A, B, and C, so I'm going to insert a line between the cout and the cin, int A, comma B, comma C, like that. I just added that line. And it's about time for me to actually copy this over into main. But what will happen is if I type in 1, 2, and 3, the 1 is going to go into the A because it's the first thing, the 2 is going to go into the B because it's the second, and the 3 is going to go into C because it's the third. All right, I'm going to take that code, copy it, paste it into my program, right underneath main. Anybody see my error? I spot it. Do you see it? Yep, that needs to be ENDL. So if you typed end like I did, and you have that error that I do, make it ENDL. So fix that line. I don't really need this arrow comment anymore, I don't think. Okay, so if I run it, it says give 3 numbers. All right, 1, space, 2, space, 3. And then when I run it, it prints out 1, 2, and 3. Now, it didn't put any spaces because I didn't put any spaces in my CIN, right? But I could have. Enter name and enter age. Notice it skipped the enter name. That puzzles me. CIN is a weird beast. Notice that mixing CIN and getLine is causing real problems. At this point, I'm going to again, get rid of the get line so that it'll stop misbehaving. So go down 4 more lines or whatever, comment out the get line, uncomment out that one. And hopefully it'll be a little bit better behaved. "12, 13, 14. It prints out 12, 13, 14, and it asks for the name. And I didn't put any spaces in, and I didn't put an ENDL in, so it looks lousy. I will go ahead and put the ENDL in because that's just too ugly. So after that, arrow C, I'm going to put ENDL. Okay, run it, but only type in one number and see what it does. And I'm going to walk around, make sure there's no typos because we've been adding things with reckless abandon. But go ahead and run it and just type in one number and hit enter. The next one. Okay, a couple of things that have occurred to me as wandering around that I forgot to fix. If you put a space there, that's not going to work. Remember in the past where I've said spacing doesn't matter? It matters in a couple of places. Can anybody take a stab at guessing why that doesn't work?
You're multiplying nothing.
Yeah. What's happening is it's trying to treat that as multiply rather than multiply and store. That's because this is one operator, but they don't have enough symbols on the keyboard to come up with. Yeah, I'm going to show y'all something. All right. Some absolutely mad geniuses wrote a computer language that requires all of those symbols as well. So you wouldn't have to use times equals. Maybe instead of times equals, it was upside down T or something like that. So the entire language was defined in symbols rather than using words. And so they made keyboards that would match that. And although you can't see it, you know, if you hit shift, it just makes the uppercase. And then if you hit control, it uses another letter. But it actually had even another key that would get it to do the character that was on the front of the keyboard. See if we can pop that open. Yeah. It actually had, along with the shift, you could get it to type in Greek, control, which we're used to, but meta would use the top row, or maybe super would, and maybe meta would do these characters along the front of the keys. Looks like that's a little Christian fish, and I have no idea what hyper does. Probably causes your keyboard to disappear or go somewhere else and blow up. I'm kidding about that. Okay, so anyways, we couldn't separate that because this is a single operator. Okay, another thing is if I come over there and your code has gotten kind of, messy like that, and it makes my little brain hurt, what I'm going to do is I'm going to highlight everything with Control A, Command A for, well, is anybody using a Mac in here? It's odd. Last C++ class I had like a contingent of 10 Mac users, so they weren't using Visual Studio. So anyways, highlight everything and then do Edit, Advanced, Format. And if you did Format Document, you probably wouldn't even have to highlight everything. And if it did its job, it fixed the broken stuff. It tabbed it out correctly. Very useful. Do try to keep your tabs going okay. And when you're copying and pasting, your tabs are never going to be okay. Like when I wrote my stuff in Notepad and then I came and I pasted it over here, the tabs weren't okay. But I can fix that.
Where did you say it? Oh, there.
So it's under Edit, Advanced, Format. And yay, it's back to being beautiful. There's some other things under Advanced. You want to make your entire thing uppercase in order to very quickly break it. Advanced, make uppercase. It's not going to work anymore. Why is that not going to work? Because all of the keywords are broken. It has to be lowercase. Cout has to be lowercase, and so on. So Control Z to undo that. I hope you didn't do it. So if you have strings, you can do stuff with them. You Python guys remember that you can get the length of a string by doing len parentheses string. Well, instead, strength is a class that has a length member. So if you wanted to print out the length of the string, you could do that. You would just call .length. Now don't type this into your program, but I guess you could. Why don't we go and do that? I'm going to put it up at the top like I always do. I keep piling stuff up at the top rather than the bottom one. String s is equal to space cadet. And if I'm curious about how long it is, cout s arrow arrow s dot length. Arrow parentheses in parentheses because it's a part of that class. It's a method call. A method is a function that is attached to an object, and strings are objects. NDL. So when it runs, it's going to print out 11. My big prediction. Yep, 11. Okay. Oh, and the other thing I asked y'all, but I didn't demonstrate it up here, is if I just type in one number, although it said give me 3, it kind of hangs out. And then the user fires you. So anyways, but you can type in a second number. Oh, why isn't it working? 14, and then it is working. And the reason why is CIN arrow arrow is ignoring all of the white space, including the inner key, the carriage return. So it treated that as one little bit of input. That is another token of input. I said it tokenized it, and that is the third one. And it didn't matter whether those were all in the same line, separated by one space, or whether they were all different on different lines. So if you use this bit where you're doing multiple arrows on the same line, it can get to the point where the user thinks that their screen is, broken because they didn't type in enough data. Give me 3 numbers, okay. That's going to work fine. Again, it just ignored all of the white space. It tokenized it. That was the first token of input, that was the second, and that was the third. You can add 2 strings together if you want. That's called concatenation. You just use the plus sign. But instead of doing addition, like it would if they were numbers, it does concatenation. So the same operator does both. Let's change this string s. Let's make it equal to space, end quote, plus, beginning quote, cadet. Now since I didn't include the space bar in there anywhere, in fact I'm getting a red underline. I hope that goes away when I build it. Huh, what do you know? Can I add 2 pointers? Alrighty. We're going to change this a little bit. I deleted that line string s. I'm going to make string word 1, W1, W2, and then s. Word 1 is equal to space. Word 2 is equal to cadet. And my final string is equal to W1 plus a space plus a W2. And I hope that works. I hope I don't have to store the space in its own string to get that to work. Yeah, that looks like it's going to work. So if I run it, it's going to, well, it's not printing it out. We should have put a print out that word just so, for our own benefit. Cout, arrow, arrow, s, arrow, arrow, NDL, just so that we see that word. All right, now it's saying space cadet. This is called concatenation, adding 2 strings together, appending that second string to the first one, except we're doing more than appending, right, because we have 3 bits of data. And although y'all haven't seen for loops yet in this language, I bet you have in others, so we're going to write a for loop that adds a whole bunch of stuff to that s. So underneath that line, for int I is equal to 0, I is less than 10, I plus plus. This looks different than the Python for loop. This looks a lot more like the Java for loop. So if you've taken Java, you're going to go, yeah, I know what that's doing. If you haven't, your eyes are going to kind of cross a little bit, but it starts to make sense. I'm not going to ask you to know what it's doing here. But anyways, S is equal to S plus googly moogly, whatever. I'm going to put a space at the front of it. There we go. And a semicolon at the end. So that's my code now. Go ahead and run it. All right, it printed out Space Cadet, googly moogly, and it has that repeated 10 times. Why is that? Because it concatenated, it added the word googly moogly to our string 10 times in a row before it ever printed it out. Copy that, paste it into our notes. Strings can be concatenated with the addition operator. Get the length of the string using dot length. So s dot length int x is equal to, well, whatever. Don't type this stuff. This is these are notes. Don't put them in your program. All right. Did adding with string concatenation, did playing with that break anybody's program give you typos? Math library functions. POW, I think we've seen a couple of times. There are other ones. Sine, cosine, and tangent. My guess is that these all use radians rather than degrees. At least that's how they did it in Python and Java. So you would have to convert from degrees if you ask the user, type in your favorite angle and they type 90. You'd have to convert it to radians first. And this isn't a math class, so I don't care. I'm not going to ask you to use those functions. Just remember that they exist. What you do is you include CMath, and you get those things. Now, we didn't have to include CMath for the POW function, so I'm not sure why we have to for the rest of these, but we do. Let's play with square root at least. Let's come and, again, add some stuff to the top of our code. So I'm going to add one more pound include. Pound include CMath, and then we're going to slow down and end our class pretty soon. Let's declare a double or a float, doesn't matter which. Float f is equal to, 3.14159. Let's square that number.
Didn't CMath require doubles for input?
It will convert them to doubles. But, okay, just for safety's sake, double f is equal to 3.14159. Now f is equal to POW f to the power of 2. We're going to square it. And then let's get another one. G, double G is equal to, I want to take the square root of it. SQRT, parentheses, f. So we've squared it, and then we took the square root. And in an ideal world, the square root would exactly equal the square. I'm still trying to get y'all to see floating point rounding errors. And let's print those numbers out. F followed by a space, and then G followed by an ENDL. And then when I run them, I never printed out the original. That was a mistake. It did equal the exact same number. Okay, I did not get a rounding error. But you see how to use that function. You see how to use square root. To get square root in, you include CMath. A lot of math functions are in the CMath library. Include CMath, and then you get square root. You get sine. Is it sine or sin?
Could this do like upper level calculus?
I'm sure there are libraries for doing complex mathematical things. This is still all pretty much junior high math. Sine, cosine, and tangent. Absolute value.
Wanted to see if I could build a program to do my math.
That would be cool. Yeah. The problem with that is that you wind up spending more time programming than it would have taken just to do the assignment. But you learn a lot of programming. So if that's your bag, then, and I mean that seriously. But it's not a time saver. Alrighty. Out of these, I just want you to memorize square root. POW, which we already knew and you don't need CMath for, and ABS. I'm going to delete that POW, but I'm going to tack it on as a comment. And POW, which is not a part of CMath. And you know what the absolute value means? Absolute value means if it's got, it just takes the magnitude of it and drops a sign. The absolute value of negative 10 is 10. All right, that's about enough. Did I give y'all a homework assignment?
Yes, but you didn't.
But I didn't what?
I don't know if it showed up in the Dropbox.
Great. And if it's stuck in the other room, then did y'all say the room was still open?
It's not.
It's not?
Yeah, because I went there.
All right. Well, let's go dig for it.